Hello students, in today's class we will discuss a very important topic of organic chemistry, that is the conversions. Yes, conversions. What are conversions? In conversions we have to convert one reactant into one product. Means reactant is given and we have to convert it into a product. Conversion may be a single step conversion or maybe of multiple step conversion. So today we will discuss about multiple step conversions. One thing you should remember that when you have to learn the conversions, when you learn all reactions of organic chemistry chapters, all chapters reaction, when you learn and understand properly, after understanding all reactions, method of preparation, chemical properties, then you have to start conversions. You should not start the conversions from first chapter. Why? Because conversions are actually linked with a number of chapters. All a number of chapter reactions are mug up and then they are mixed together, and then questions of conversion you can solve. So how many type of conversion may be, or we can say our organic reactions can be of three type. First reaction, that is called normal reactions or normal conversion. Now, what are normal reactions? Normal reactions are those reactions in which number of carbon in reactant and product are same. Suppose we are taking 2 carbon reactant, then our product will be of 2 carbon. Means number of carbon, if reactant and product number of carbon are same, then that is called normal reaction or normal conversion. Then step up reaction, or you can say step up conversion. Now what are step up conversion? Step up conversion or step up reaction are those reactions in which number of carbon in product is high and number of carbon in reactant is low. So step up, its name suggests that number of carbon in product is more than number of carbon in reactant. Those type of conversions or those type of reactions are known as step up reaction or step up conversion. And another are, that is step down conversion. Step down conversion. Now, what are step down conversion? Its name suggests that number of carbon in reactant is more than number of carbon in product. So suppose in any conversion or in any reaction, if number of carbon are decreasing, then number of carbon in product should be less than the number of carbon in reactant. These type of conversions or these type of reactions are known as step down reaction. In our whole syllabus or in NCRT, or we can say in syllabus of JEE Neet, you can say 97 to 96 to 97% reactions are normal reactions. Only 3 to 4% reactions are step down or step up reactions. So step down or step up reactions are very less reactions in NCRT. That's why these reactions are very important. Step up and step down, these reactions are less in number, but these reactions are very, very important reactions, and these conversions are very important conversions. So let's start step up conversion. Step up conversion in organic chemistry. So when we discuss step up conversion, then it's sure that number of carbon in product will be more than the number of carbon in reactant. So we will discuss how can we perform these step up conversions. So for step up conversions, especially for those conversions in which reactant and product are of same family, they are of same family, but just they differ in 1 or 2 carbon. For example, if we want to convert CH3OH into CH3 CH2OH, means we want to convert methanol into ethanol. How can we convert? So let's understand. First of all, we should know in these type of conversions, these conversions in which reactant and product are of same family and they are just differing one carbon. So in these conversions we have to approach or we have to get a linking reaction. Which one is that linking reaction? That linking reaction is that CH3Cl, or we can say any alkyl halide, RCl. When RCl react with KCN, potassium cyanide, alkyl halide when react with potassium cyanide, then they gets converted into RCN, means alkyl cyanide, or we can say alkane nitrile. So that is the linking reaction. Linking reaction. What is the meaning of linking reaction? Linking reaction means we can understand that here is number of carbon is increasing. One carbon we are incorporated in our reactant through KCN. So when alkyl halide react with the KCN, then one carbon will be added in this reaction. So we should convert our reactant to into alkyl halide, and we know the alkyl halide method of alcohols are the best source of preparation of alkyl halide. So we should convert our reactant into first alcohol, then alcohol can be converted into alkyl halide, then alkyl halide, from alkyl halide we can prepare cyanide. So through this linking reaction we can incorporate one carbon in our reactant. So let's start, or let's understand how can we perform. So first of all, CH3OH means methanol should be converted into alkyl halide. We can use SOCl2, PCl5, PCl3, any chlorinating agent. This chlorinating agent will convert this alcohol into alkyl halide. CH3Cl means OH group will be replaced by Cl group. Now we can perform that, we can use potassium cyanide, and through potassium cyanide we can convert alkyl halide into alkyl cyanide. So CH3Cn. Now you can observe that number of carbon are increased. Here is one carbon, here is also one carbon, but here is two carbon. So we can say we have increased the number of carbon. Now, but we want to prepare alcohol. It's okay. So when we can reduce it, we can reduce it. How can we reduce it? LiAlH4, lithium aluminium hydride. Its reduction, through its reduction we can get CH3, CH2, NH2. Now you can clearly observe that number of carbon are increased. We are starting from one carbon, but here is two carbon. Now NH2 group can be converted into OH group through HNO2 or nitrous acid, we can say. So when we treat it with NaNO2 plus HCl, it will give us HNO2, or we can say nitrous acid. It is a well known reaction of amines, 1-degree amines. Then we will get CH3CH2OH, means your NH2 group will convert into OH. You can observe that we have converted that methanol into ethanol, means number of carbon, one carbon is increased in our product. Next example we can take. Suppose we want to convert CH3NH2, means 1-degree amine, that is methane amine, into ethane amine, CH3CH2NH2. We can observe that it is also step up conversion, because number of carbon in reactant is 1, but number of carbon in product is 2, and these both reactant and product are belong to same family. That's why we can use this trick. Which was the trick? We have to we should reach to that linking reaction. So how can we get alkyl halide from aniline? Suppose from amine, CH3NH2. So first of all, this NH2 directly, this NH2 group cannot convert directly into a halogen group. That's why we want to prepare, it's that NH2 should be should be converted into OH group. How NH2 group can be converted into OH group? That is the best method. You have to use NaNO2 plus HCl or nitrous acid, as we have observed in our last question. So when we treat it with NaNO2 plus HCl or nitrous acid, this NH2 group will convert into OH group. So CH3OH. Now we can convert into alkyl halide. How? We can use SOCl2, PCl3, PCl5, or you can say any chlorinating agent through which OH group can convert into Cl group. So this CH3OH can be converted into CH3Cl. Now the linking reaction means we have to use KCN and we can convert it into CH3CN. So ultimately, again, we have incorporated one carbon in our reactant. Means number of carbon here are 2, 1, 2, but here is 1. Next, but we want to prepare CH3CH2NH2, so we have to reduce it, or through reduction LiAlH4. We can prepare CH3CH2NH2. So we have converted our methane amine into ethane amine as in question given. Next is another question. Let's try another question. We want to convert CH3COOH, means ethanoic acid, into propanoic acid, CH3 CH2COOH. How can we convert ethanoic acid into propanoic acid? So we can observe and we can understand that it is a step up conversion. It is how it is step up conversion. Obviously, number of carbon in reactant are 2, in product number of carbon are 3. So it is a step up conversion. Because reactant and product both belong to same family, so in this conversion we can also use that trick we have used in our previous question. So suppose we have CH3COOH. Directly we cannot convert it into that alkyl halide. What is our aim? Our aim is that we have to reach up to our linking reaction, means we have to convert it into alkyl halide. Now we cannot convert directly it into alkyl halide. So what are the best source for alkyl halide preparation? Alcohol are the best source, as we have discussed earlier, for preparation of alkyl halide. That's why we will convert it into alcohol. How can we convert it into alcohol? Obviously we can convert by reduction. So by reduction we can use directly LiAlH4 or any other reducing agent we can use, and then we can convert it into alcohol. Same number of carbon of alcohol we will get, CH3 CH2OH, means 2 carbon. Here is also 2 carbon. Now we can convert it into alkyl halide by using a chlorinating agent, for example SOCl2 or PCl3 or PCl5, any chlorinating agent. Through this, OH group will be leave as a leaving group, and Cl will be attached as a nucleophile, and our product will be CH3 CH2 Cl. But here number of carbon already 2. Number of carbon are not increasing. Number of carbon will increase in this reaction. Now in this reaction, number of carbon will increase when we react it with KCN. Yes, now number of carbon will be increase. Cl will be leave as a leaving group, and cyanide will come as a nucleophile and will attach to this carbon, and we will get CH3 CH2 Cn. Now number of carbon are increased. 1, 2, 3, 3 carbon are there. So we have increased the number of carbon. But what was our question? Our question was we have to convert that ethanoic acid into propanoic acid. It's not propanoic acid. We can convert into propanoic acid. How can we convert it into propanoic acid? CN, cyanide. If we perform complete acidic hydrolysis of cyanide, then it get converted into carboxylic acid. So it's acidic hydrolysis, or we can say complete acidic hydrolysis. Hydrolysis will give us 3 carbon carboxylic acid, means CH3, CH2, COOH. So it's a very important method of preparation, or we can say it's very important trick of step-up conversion, especially for those type of step-up conversion in which number of carbon is increasing and reactant and product both belong to same family. This type of step-up conversion we can perform through this trick. We have a lot of other reagents also which we can use for step-up conversion. That is like example RMGX, Grignard reagent. Grignard reagent. So Grignard reagent also a good reagent which we can use in step-up conversion. That we will discuss in our next class. Thank you.